So far, what you've seen is that if we tune all the hyperparameters of our neural network model, that is, say, for example, I find the best number of neurons that gives me highest accuracy or minimum MAE on my validation set. Say I also found out the number of epochs I need, ideally, to get there. And say I found all the good parameters that I need, my learning, optimization algorithm, and so on. Now the question then becomes, how do I catch exactly the best model when, at which, during the time when it has the minimum loss on the validation set? That is, say for example, I initially set 200 epochs and then my loss keeps going down. And let's say exactly when I stop at 200, next time when I train it, my loss may be slightly higher on the validation set exactly when it's 200. So the question is, I know that approximately 200 or around that is a good number of epochs to use. How do I make sure that I catch the best model on the validation set within those 200 epochs? Now, the way to do that is to use the techniques of early stopping and model checkpointing. So what model checkpointing does is during training in every epoch, if I checkpoint the best model based on my validation loss, then every time there's a better validation loss or lower loss encountered, it's going to save the model to some file that you mentioned. So this way, once your training is over, we don't have to worry about how many epochs or like, did I overtrain or undertrain? Because the best model that had the highest performance on the validation set will automatically be saved. So that's model checkpointing. Now we can also do something known as early stopping. What that means is, say my total number of epochs that I've set is 1000. And what I would like to do is, if my model's validation accuracy does not improve for, say, 100 epochs, then I would like to stop the training because I see that there's no point in training further. This is particularly helpful when one epoch takes a lot of time to train, say a few hours or something like that. So then what this early stopping allows you to do is you can specify how long you can wait until you don't see an improvement on the validation set. And then after waiting those many epochs, it automatically stops the training. What's very interesting about early stopping is that, say the model starts training and then let's say it found a better loss after 25 epochs, and then after, let's say, 25 epochs, say if your patience, that is your wait time, is set to 100 epochs for early stopping, then after 25 epochs, it tries to check if it can find a better model or a lower loss on the validation set. And say after 25 epochs, maybe when it reaches 50, it found a better model. That is, the loss went slightly lower on the validation set. So then it resets its counter so that it starts counting again. So before stopping the training, it's going to wait for fresh 100 epochs of training for which the validation accuracy did not increase or the loss did not decrease. And then it's going to stop training. So in this way, early stopping and model checkpointing really help us capture the best model and also stop the training without having to train for a really long time when the improvement is actually not happening anymore. Now here's an example learning curve. You can see that in x-axis I have my epochs, and in y-axis, say this is my loss. The orange curve is for the validation set and the blue curve is for the training set. Obviously, the more we train, the higher the epochs. The loss on the training set will continuously go down. It will keep going down. Roughly, sometimes it may go up, but overall the trend is that it's going down. On the validation set, however, we see that a minimum loss is observed right at epoch 2. And then we can see that for these many epochs, we did not observe any improvement. And after this, we observed a better model here. And then after that, we observed a really good model at this point. So what checkpointing does is As soon as it hits a lower loss on the validation set, it saves this model into your model file, and then it doesn't save all of these models. And as soon as it gets here, it saves this model too. And then once it gets here, it saves this model too. So it overwrites, and at the end, what you have is this model. And say if you train up to 16 epochs and then stop right here, in other words, if you didn't have any checkpointing, then this is the model that you would have in your final after your final training. But with checkpointing, even after your training finishes, after 16 epochs, you will still have this model saved into a file. Now, something that we have to remember when we do checkpointing is to load this model again after finishing the training. So after we do model.fit, and then after that we have to also do model.load, model.load, and whatever model we specify, the file name, to load the model back again.